centroid real quick? Centroid. Quickly just drop some knowledge on me. What do you know about centroid? I know it's the intersection of the medians. What's so special about a centroid? Breaks a median up into what? 2 to 1, 2 to 1, 2 to 1. Here's what I want to do today. I don't want to talk about a median. I want to talk about just a plain old line segment, and I want to break that up into different ratios other than 2 to 1. Okay, so that's what we're going to do today. Is we're going to take line segments, and we're going to start breaking them up into different ratios. So the first line segment I have there, can you put a ratio of 2 to 3 next to it? On your notes, put a ratio of 2 to 3 like I have up on the board. I want to find the point on this line segment that breaks it up into a ratio of 2 to 3. What does it mean? What's that 2 to 3 actually mean? Here's what it means. When I find that point on AB, I'm going to have two congruent line segments to the left and 3 congruent line segments to the right. So wherever this point is on AB, I'm going to look to the left and I'm going to have 2 congruent line segments. I'm going to look to the right of it and I'm going to have 3. So in total, how many congruent parts should I have on AB in total? 5. So what I want you to do right now, using points, is please break AB up into 5 congruent parts using points. I'm not going to come around and actually measure if they're 5 congruent parts, but please eyeball it right now. Put points on AB so it is broken up into 5 congruent parts. So just put a point, so you end up with 5 congruent parts of AB. There you go, about 5, right? 5 congruent parts broken up into. All right, now, can you find the point that represents the 2 to 3? It's broken up into 2 to the left, 3 to the right. Can you draw an arrow to it right now on your paper? Where is the, out of all these points that are on the line segment, which one represents the one that breaks it up into 2 to 3? 2 to the left, 3 to the right. And hopefully we are pointing to that one. Right there. Because look, 2 to the left, 1, 2, 3 to the right. That is the point that breaks AB up into a ratio of 2 to 3. All right? Let's keep doing this. Next one, write a ratio of 1 to 3 next to it for me, please. 1 to 3. Where would the point be located? So you have 1 segment to the left, 3 congruent segments to the right. Before you find that point, how many equal parts do I need to break it up into then? 4 equal parts. Go ahead, break it up into 4 equal parts. Four equal parts. Go ahead, point to where the 1 to 3 point would be, please. 1 to the left, 3 to the right. Where is that? And it should be right here. Okay, a couple more so we get the hang of this. 2 to 1. Find me a point on AB now that breaks it up into 2 to 1. First thing you're doing is breaking it up into 3 equal parts. It's kind of like a median. And we should be pointing to that one right there, 2 to 1. And yeah, I'm going to get a little nuts here with the next one. 3 to 5. Find me 3 to 5. Oh, this guy. Are you kidding me? Nope, I'm serious. Let's go. Suck it up. 3 to 5. Do your best. Do your best to make them to 8 congruent parts. And then where's that point? 3 to the left, 5 to the right. There it is. And then the final one here, this diagonal one down below. Let's go 1 to 1 here. And then I'm going to have a follow-up question. Let's go 1 to 1. Vocab term. You know the name for that point you're pointing to. Midpoint. Good job. Yeah, that's the midpoint. All right, well, that would be fun if I just took line segments and gave you ratios. You could make pretty dots there. I want to put these on a graph now. Okay, so you're going to put these on a graph. AB is going to be on a graph. And you're going to find the coordinate of this point, that point. What is the XY point of it all? All right. All right, before we do anything, actually go ahead and graph it, and then I'll start talking. Go ahead and graph it. Most of you are going to graph it, if I'm talking or not. So. Yep, please connect it with the straight edge. Okay, the process we're doing today of breaking up these line segments, the process is called partitioning. Okay, it's called partitioning. You might have heard that word before, like you go to an office building and things are partitioned, right? Divided up. I think if you go to LMC, I've only been there like 2 times in 23 years. I think reading's overrated, but if you ever go to the LMC, I think they have like that quiet study area. They have those things next, the little cubicle, like those are partitions. You're dividing things up. Okay, so that's what partition means. If you keep reading the directions, I want you guys to become familiar with a phrase up here that you're going to see every time in these questions, and that's right here. Find a point on the directed line segment AB. What they're telling you is to find the point, you need to start at A. So start at point A and go to point B. And some of you are like, why does it matter? Well, actually, remember this old 3 to 5? If I went from B to A, that's a totally different point you're pointing to. Okay, so the directed tells you what order to go to. And look, guys, in this class, we're only going to go from A to B. I'm not going to try to trick you and go from B to A. But that's why that's there. So you understand when you see that phrase, directed line segment AB, we are going to start at A and go towards B. All right, so here we go. We're going to break it up. I need to know where on this line segment is a ratio of 2 to 3. 2 to 2 to the left, 3 to the right. So do the same thing you just did with the 6 line segments on the previous page. How many parts do you want me to break it up into? 5 congruent parts. Don't do it on AB though, because this is actual numbers now. I need to break it up into 5 congruent parts first before I find that point. And on a graph, you have an X and a Y axis. So I need to break the X axis up into 5 parts and the Y axis up into 5 parts. So we're going to do this procedure twice. First one we're going to do is for the X axis. We're going to break it up into 5 congruent parts. What are my X coordinates here? For A and B, what are my X coordinates? Am I going with that one there? I'll get to you. Alejandro, what are my X coordinates for A and B? -3. So we're going from -3 to 2. Next person, how far is that? From -3 to 2. Count it or figure that out in your head. We don't need the distance formula here. -3 to 2. How many units apart are they? Alejandro, back to you. Everyone agrees they are 5 units apart. And you just told me you need to break it up into 5 equal parts. 5 units away. Break it up into 5 equal parts, you get 1. Now, what's that 1 telling us? Ready? Everyone visualize you're on the x-axis. Go 1 unit. That's where one of those points would go. Go another unit. That's where one of those points. I keep going. I'm going to end up at B sooner or later on the x-axis. All right, next big question. All right, I understand I go 1 unit every time, but how many times do I need to go 1 unit to get to this point? How many times do I need to go 1 unit to get to that point? Well, look back here. 2 to 3, you guys always went to the second point you graphed there, right? 1 to 3, you went to the first point. 3 to 5, you went to the third point. So the first number in the ratio always tells you how many you need to go. So how many times do you have to go 1 unit? What's the first number in our ratio? I need to go 2 times 1 unit. So I go 1 unit, I'm there. So that tells me I need to go 2 total units to get to where I need to go. 2 total units from where? Wherever we started. Go back, look at the 2 coordinates. Where did we start on the x-axis? At what number did we start on the x-axis? Oh, there we go. Jake, just to hear from you. Don't screw it up. What number did we start on the x-axis? -3. So from -3, it says you better go over 2 units to get to that point. Okay, so that's what 2 total units means. From wherever you started, go that many units. And where do I end up on the x-axis? 1 less. Sophia, where do I end up? I end up at -1. On the x-axis. I still need to pair it with a y in a minute. Questions on what 1 doesn't make you great here. We still got to do it again. All right, where am I going to end up on the y-axis? Let's do the same thing now. Cut the y-axis into 5 equal parts. First thing is, what are the y coordinates? Gerard, what are my y coordinates?
-4, 0.
Okay, so everyone think I'm going from -4 to 0. -4 up to 0. How many units am I going there? Logan? 4 units. And I need to cut it into equal parts of 5. Sorry, guys. Sometimes the numbers aren't going to be pretty. Right? Deal with it. You're in an above average math class. So 4 over 5. 0.8 now. 0.8 every time. So again, on the y-axis now. Hey, I go 0.8. 0.8. 0.8. How many times do I need to go 0.8? 0.8. How many times before I get to my partition point? What's the first number in the ratio again? 2. You're never using the second number. I'm not even going to go into when you would ever use the second number in the ratio. You always use the first number. Okay, we never sniff the second number in the ratio. So I'm going to go 0.8 twice. Okay, we always use that first number in the ratio. Okay, everyone always associates, oh, we're doing the y-axis, so that's the second. Nope, always use the first. All right, how many total units do I need to go then? Alexa, how many total units? Good talk. I'm talking to nobody. All right, Orla, take over. How many total units? 1.6. That is not where we end up. That is how much you have to move. This is why you're always going to see me write total units after this step. That is not where I end up. That is how many I move from what starting coordinate. I'll get to you there. Alejandro, where did I start on the y-axis? -4. So everybody go up 1.6 from -4. And where do I end up on the y-axis now? David. -4 plus 1.6. -2.4. Is that right? I don't know. Is it? Yep. -2.4. Now, maybe. Let's put these two together, and I'll talk about how you can check if you're right or wrong. So we're going to say that point is -1, -2.4. If that's your answer, it better land on the line. So I want you to graph to your best ability -1, -2.4, and it better land on the line. Because if it's going to cut AB into a ratio of 2 to 3, it better land on your line here. -1, negative. Yep, looks good to me. And also, whoa, I'm not even done. It should land on your line and make sense with the ratio. Remember what 2 to 3 meant. 2 to the left, 3 to the right. What one should be smaller up here? The one to the left. And look, yeah, that is smaller than the one to the right. So yes, it should land on your line and make sense with your ratio. Oh, one doesn't make you great. I know it's awkward, uncomfortable now, but we got 2 more to do before you do one on your own. Anything you want to ask on that one? And again, a girl asked me in my last period class, well, isn't that like 1-to-1 because you only put 1 point on? But remember, that's the point. If I had you guys break it up into 5 equal parts, that would be my 2 to 3 point. Okay, so that's what we are breaking it up into 5 equal points, but we're just showing the second point, and that's it. All right, next up, graph it. Our ratio now is 4-to-1, which means first thing we need to do is break it up into how many equal parts before I get to 4-to-1. Solar, how many equal points? Parts. 4-to-1 is my ratio, so the first thing I need to do is break AB up into how many equal parts? 5 equal parts, yep. And that's what I'm going to do first for both the X and the Y axis. All right, X-axis, kids, X-axis. What are the X coordinates? Gabby, what are my X coordinates?
-2, 2.
Yep. All right, so everyone think in your mind, you're going from -2 to 2 on the X-axis. Count actually on here, if you have to. How far apart are they? What's the distance between them, Alejandro? 4, yep. 4 units apart. Cut it up into equal parts of 5. Not pretty, I know, but we're dealing with it. 0.8 units every time. Use your ratio now. How many times do you have to move 0.8 to get there? How many times do you have to go 0.8 looking at the ratio? Solar again? Where'd you get 2 from? What's the ratio?
4.
What's the first number in the ratio? 4. That's the number you have to travel. 4 times going 0.8. Always the first number in the ratio. Always. Okay, we're how many units total now? 0.8. Solar again, when you have it, 0.8 times 4. 3.2. I'm going to keep yelling this. That's not where you end up. That's how many total units you got to move. From where? Where did I start on the y-axis here? Oh, 3-bagger! Everyone see that? The rare 3-bagger again. Did this happen yesterday? Or is it another class? Obviously another class because everyone's just staring at me. The rare 3-bagger. You want to know how rare it is? A 3-bagger? There's what? How many numbers did I have to choose from here? 19? So you have a 1 out of 19 shot every time I do the random number generator. Second time, you have a 1 out of 19 shot. Now, 3rd bagger, would have a 1 out of 19 shot. Watch how small this percentage is that just happened right now. Times 1 out of times 100. Here you go. Here's the percentage that just happened. Less than 0.14%. That's a percent, not like that's an actual percent that just happened. Okay. So less than, I don't even, 1,000th of a percent right there. Less than that. So there you go. Rare moment. 3-bagger. Very rarely. It happened yesterday in another class too, but where did I start? Back to what I needed here, Solar. Where on the y-axis am I starting? I'm sorry, x-axis. You had it right. Go ahead. -2. So from -2, I'm going to go over 3.2. Oh boy, could be the rare like once a year 4-bagger I get. Once a year 4-bagger. No, not this time. Sorry, Alexa, not even here. Come on, one job. Alex, what do I end up here on the x-axis? 1.2. Yep. It's just like anybody know that kid that sneezes just like bam, 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 all in a row, like 4 or 5 times in a row. Like, there's some you got to get checked out if you're above like. I think you got to get checked out if you're above like 4 sneezes in a row. I think so. I'll have to look after we're done here, but I'm pretty sure. Not around here, but somewhere in the United States, there was a girl that like has some condition where she just continuously sneezes, and it was like a record. Like she sneezed for like hours on end. Just, I'll have to look it up before we leave. Yeah. Like it's one of those. It's funny, but you shouldn't be laughing type deal. You know what I'm saying? Like, but poor girl, but it's pretty funny. I'll look it up here at the end. All right, y-axis. We got to get there first. Y-axis. What? Ooh, all right. There is a trap with these partitions. It seems pretty easy, right, the process, but there is a trap you have to watch out for, and here it comes. Orla, what are my y coordinates? 5 to -3. All right, 5 to -3. How many units apart are they? As you go from 5 to -3, how many units apart, Athena?
8.
Okay, they are 8. I agree with that. Here's what you got to, it hasn't happened yet, so I haven't spoken about it. 5 to -3. Notice I'm going down 8 units. So to show you're going down 8 units, it needs to be -8. Also, if you're going to the left on the x-axis, you also have to make it negative. All right, but watch out. I'll show you why that's important at the end of this problem. Still cutting it up into equal parts of 5. So now I'm going down, what was that, 1.6? Down 1.6 every time. How many times am I going down 1.6 according to the ratio? How many times going down 1.6? Solar, here you go while you're blowing your nose. Perfect. How many? 4 times. Good. You always use that first number in the ratio. -6.4, right? Down 6.4 total units. Again, that's how much you're moving, not where you finish. Where did we start on the y-axis? 1, 4. Liliana, where'd you start on the y-axis? 5. Good. So everybody go down 6.4. Where did we end up on the y-axis, Jake? -1.4. All right, let's see if that makes sense, everybody now. 1.2, -1.4. Go to your graph. Let's go to our graph. Over 1.2, down 1.4. Does this make sense? 1.2, down 2 and a little bit more, about right there. Okay, it's on the line, and look at the ratio, 4 to 1. Much bigger to the left, huh? Much bigger, yes. Please do not go on to the next one. Remember I told you about the trap. Okay? If you did not notice it was negative, here's what would have happened. Ready? Okay, so you left it +8. So that would have been positive 6.4, adding instead of subtracting. And we would have got a y coordinate instead of 11.4. This is why you check. Exactly the example of why you check. Ready? 1.2. 11.4. Something went wrong. That's why you check. All right. It's okay if you fell in the trap if you check. All right. Clearly you fell into the trap because that point's way up there, not even close to the line. All good. Questions, comments, any concerns? All right. One more together, and then I'm going to have you guys do one on your own. And then we're done for the day here. All right. Throw up your graph here. All right, ratio 3 to 7. Before I start any calculations, I need to break everything up into how many equal parts. Ratio is 3 to 7. David, how many equal parts? 10 congruent parts. Perfect. Let's start with the x-axis now. All right, look at the coordinates. Look at the coordinates. Choom, Sammy, what are my x-coordinates?
-2 and 4.
-2. Okay, so first thing I want you to start getting the habit of -2 to 4. That's in the positive direction, right? -2 to 4. So whatever distance it is can remain positive. And what is that distance from -2 to 4? How far apart are they? Solar, how far apart? 6 units away. Again, leave it positive because we're going. Everyone okay what I mean by leave it positive? Because when you go from -2 to 4, this is in the positive direction. Cut it up into 10 equal parts. So we're going to go 0.6 every time. Next question, of course, is how many times are we moving 0.6? Look back at your ratio. How many times am I moving 0.6? Orla? 3 times. Yep. For a total of 1.8 units. Again, I'm a broken record, but got to yell it. That is not where you end. That is how many units you move. And speaking of moving, what was my initial? Solar was my first x coordinate.
-2.
So from -2, everyone go over 1.8. Where am I landing on the x-axis for my point? Shoom, Alejandro, what do you got back there?
0.2.
Which one? Okay, I almost had you. I was ready to light you up too. You kept positive 0.2. I'll get there before the end of the year. All right, -0.2. Y-axis time. What are your y coordinates? You guys are doing a good job here. Keep it up, Gerard. Y coordinates.
1 and 5.
Okay, everyone. Hey, quick check. 1 to 5, positive or negative direction? Positive. Okay, so whatever you give me here will remain positive. 1 to 5, how many units apart are they? Solar, back to you.
4.
4 units away. Keep it positive because I'm going up. 10 equal parts. So we're going to go 0.4 every time. All right, every time you move 0.4, how many times are you going to move 0.4? Jake, how many times are you going to move 0.4?
3.
3 times, yep. Always the first number in the ratio. And that's going to be 1.2. Total units. And somebody finish this here now. What was my starting y coordinate? 18. Amelia, starting y coordinate? 1. Go over 1.2. I should end up where on the y-axis now? Going quick. Julia,
1.2.
what do you have? Yeah, I got that. Thanks. Where do I end up when I start at 1? You all right? Am I getting you rattled? 2.2, good. Maybe, right? Maybe. Maybe this is my answer. Check it. Check it. Go to the left, ready? Left just a little bit, negative 0.2 up, 2.2 units. Yep, I look pretty confident. Does that fit into 3 to 7? Does it look like it fits into 3 to 7? Much smaller to the left than to the right. Yep, looks good. 3 to 7. And you guys are on your own for this one, and you're going to call me over if you think you have it. Breaking that up into a ratio of 1 to 1. I need some work shown as well. You can't just put a point on your graph and say, there it is. Okay, so once you have it, call me over. If you get it correct, the rest of the time is yours. Before you call me over, you should be pretty confident because you've already checked that that point is actually on your line segment. So, okay, we're good. There is no assignment tonight. Once I check you for this point, you're good to go.